Okay, so we have a system of inequalities, so it's two or more. We're going to stick with just two, okay? The solution is our overlapping region, so it's the points that satisfy both inequalities, okay? Our first inequality here, the y is not by itself. You just told me to get the y on its own, I have to subtract the x to the other side. I have y by itself, we are greater than, we have negative x and a negative 1 on the same side. Okay, so I'm going to graph this one first. Okay. When I graph this, is it going to be a solid or a dashed line? It's going to be dashed, good. And are we going to shade above or below it? We will shade above or greater than, right? All of my y's are greater than the line. Does that make sense? So the y's we shade have to be above it. We're going up. Where does this line start? So we're going to go down to negative 1. Good. What is our slope this time? Negative 1, which means we go down 1 and over 1. So we're going to go down 1, over 1. All right, and remember to go backwards, we can always go up and back. So it's the opposite of what I did to move forward. To go backwards, we're going to go up instead of down. Okay, and you told me already we're going to connect this with a dashed line. And when it comes to shading, we are going to be above or greater than. So do this very lightly, because this is not my answer yet. I want to know where it's crossing with the next piece, right? So our y-intercept, greater than, means above. So we are above my line. So lightly shade above. All right. Our next equation is x minus y is greater than 5. And I'm going to use my blue highlighter when I do this one. Okay. Is this y by itself? No. I have an x and a negative to get rid of. Okay. How do I move the x? Just like last time, I subtracted over. Good. So now I have negative y is greater than, I have a negative x, and I have a positive y, a positive 5, excuse me. So you've just moved the x to the other side. My y has a negative attached to it. So what do I do there? I have to divide everything by that negative. Okay, the negative can't be there, so the negative has to be divided out of everything. What do I have to do since I divided by a negative? Thank you, we have to flip our sign. So this is y is now less than. Negative x over negative 1 makes it a positive 1. And then 5 divided by negative 1 makes it negative 5. If you want to write a 1 in front of this x, you can. It's not going to be wrong. If that helps you see it better, go for it. Okay. So now let's graph this one. Where does this line start? At where? Negative 5. Good. 1, 2, 3, 4, 5. Remember, always make that one a little bit bigger because we know we're going to use that to shade later. How are we going to move from here? Up and over 1. Okay. Are these being connected by a solid or dashed line? By a dashed. Good. Okay. And we're grading up, we are shading above or below because we are now less than. We're less than, so we're going to be below the y-intercept. So we're everything down here. Alright. So, you see that corner on the right side of the page? That is our answer. That is our shaded region right here. Our overlapping shaded region. Anything in here would satisfy both of the original inequalities. Yeah. Okay? So if I asked you, is the origin a solution to this system of inequalities, would you say yes or no? The origin is right here. Is that in my green? No. So is it a solution to the inequalities? No, it would not work. Okay? What if I plugged in, what if I used the point 22? Would that work? Up here in the yellow? Is that a solution to the system? It has to be a solution to both. Okay? So what if I did, let's see here, 1, 2, 3, 4. What if I did 5 and then -3? That is a solution to the systems. Oh, forgot my negative. 5, dang it. 5 and -3 would be a solution to everything. Hold on, it erased. The answer is anything in the green. Anything in the green is an answer. Everything in the green is an answer. I'm just asking you, if I were to pick certain points, would they or would they not be a part of my solution? Okay? So the origin was no. Okay? The 0.22 is a no. The 0.5, -3, right here, that's the... Okay, so any point in the green would be a solution. Okay, the entire green overlapping region is a solution to both systems. Okay, let's do another one. Okay, let's move on over here to number 2. What's that? I'm sorry? No, you can use whatever you want to. Nope, as long as you can tell where they overlap. All right, so number 2. I have -x plus 3y is less than 21, and I have y is greater than or equal to -x plus 4. Okay, so like last time, let's start with our first one. Okay, that one is not ready. We have to do some rearranging first. Okay, so -x plus 3y is less than 21. Okay. What do I move first? What do I always move first? My x, and how do I move it? Yes, we're going to add it. So now I have 3y is less than, I have a positive x and a positive 21. Okay. I got to get rid of my 3 that's attached to my y. How do I get rid of that 3? Good. Divide every single thing by 3. What number is technically in front of this x that we don't see? A 1. Good. Do I flip my sign because I divided by positive 3? Nope. 1 over 3 just stays 1 over 3. Can't do anything about it. How about 21 over 3? 7. Antonio, it's a little loud. Okay. Where does this line start? 7 on my x or 7 on my y? 7 on my y. Good. 1, 2, 3, 4, 5, 6. Here's my 7. Our positive y's are also the positive b's. They're the same. They mean the same thing. How do I move from here? So we're looking at the 1 and the 3. Why is it up instead of down? It's a positive. Good. Up 1 over 3. Up 1 over 3. I could go backwards by doing down and then backwards 3. Okay. Am I going to connect these with a solid or dashed line? These get dashed. Good. All right. And are we going to shade above or below it if my symbol is less than? We're going to shade below. So everything down here. All right. Okay. Our next inequality is y is greater than or equal to negative x plus 4. Do I have to move anything? No, it's ready to go. Okay. So, where is that line going to start? At positive 4. 1, 2, 3, 4. How are we going to move? Down 1 over 1. Because this one was negative. We can also go up and back. Are these going to be connected by a solid or dashed line? Solid this time. Good, because we were equal to, right? All right, and this guy, we are shading where? Above. So find it and go up. And blue and yellow are making green, and it looks like it's this region on the right side again. So anything in my green would be a solution. So I'm going to ask you this every time. Is the origin a solution to my system of inequalities? Here's the origin. Is that a solution to the system of inequalities? Is it in my overlapping region? It is not. So is it a solution? No. It has to be in the overlapping region. Okay? Who could give me a point that is in the overlapping region? Which one? Up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Yes, I would agree. So 0.57 would work. Okay. Is that the only answer? No. As long as it falls in the green, it would be a solution. So that one's good to go. All right. We good? Okay. So, number 3. Here we go. Our first equation is x minus 4y is less than or equal to positive 24. All right, I'll do purple for this one. Okay. So we have x minus 4y less than or equal to 24. Is y by itself? No, I have an x and a negative 4 in my way. What do we always move first? The x. How am I moving this x? We are going to subtract it. So we have negative 4y less than or equal. I have negative x and we have positive 24. Now what? Divide by what? Negative 4. There we go. Does dividing by negative 4 flip my sign? Yes. Good. So now it's greater than or equal to. Yeah, this will be above. Negative x over negative 4. What do you think? Negative over negative becomes a positive. What number is technically in front of that x?
1.
A 1, right? So it's going to be just 1 over 4. But now it's just positive. 24 over negative 4.
Negative 6.
Negative 6. All right. So now this is ready to graph. Where am I going to start the graph? On the y. Good. 1, 2, 3, 4, 5, 6. And how are we going to move from here? Good. How do I know it's up 1? Because it's positive. Good. I can go down and backwards. Will these points be connected by a dashed or solid line? A solid line. Good. How do I know that? Yeah, we have equal to in there. Good. And someone did say it earlier, but just to remember, where are we going to shade? Above. Good, because we are greater than. So we're going, all my y's are greater than negative 6. So they're all going to be up here. All right. Next one. We have 2x minus y is greater than or equal to negative 1. So I'm going to write the problem down. 2x minus y greater than or equal to negative 1. Is the y by itself? No. There's a negative. And what else is in my way? The 2x. What do I move first? The x. How am I going to move it? Yeah. Okay, so we still have negative y. I thought you had one of those like clapper toys. I was like, yes. We have negative 2x and we have negative 1 on this side. Is my equation good to graph? Say no. Why not? Why is it not done? What else do I have to do? Yeah, we get to divide by negative 1. So that way y is by itself. And I heard Jalen say it, that's going to flip my sign. Negative 2 over negative 1 becomes positive 2x. Negative 1 over negative 1 becomes positive 1. Whoa. Okay. Where is this line going to start? Oh, where is it going to start? On the 1, on the x, or on the y? On the y, good. Now, how is it going to move? Good, up 2 and over 1 this time. It's a positive 2. All constants are being divided by a 1. Will these points be connected by a solid or dashed line? Good. This one's solid. How do I know? Thank you. Because of the equal to, yes. All right. Where is this one being shaded? Above or below? Are my y's under or above the line? My y's are less than. My y's are below, so I want all the y's underneath it. So where my shades are overlapping each other is this top corner, this top right corner. All right, you know what I'm going to ask you. Is the origin a solution to this system? Is it? Yes, this time it is. It's in the, where they overlap. What else is a solution? Where the point would work. Give me a coordinate point. Down 6 over 4, 1, 2, 3. So that wouldn't work for the green. Yes. So instead of down 6, what if we went like down 5 over 3? Ooh, barely, but yes, that would work. If we did down 2 and over 4, that would be okay. So that's probably going to be a second part of questions. Is, okay, you did it, now, hey, does this point work? Okay, so as long as where it crosses over, it works. How else could I test points?
So the point is the green part means it works.
Yes, the green part means it works. You could also put them into your original equations. So over here, is 0 less than 24? Yes. Is 0 greater than negative 1? Yes. So that proves the origin works too, because you could plug it in. Okay. All right, probably got time for one more. Yeah. We'll finish notes tomorrow, and then I'll move the worksheet to Friday, and I'll move the online thing to Monday. Because I want to get through all. These are all really good, so I want to do all these notes. All right, here we go. Number 4. I have x is less than negative 4. I also have 3x plus 2y is less than or equal to negative 2. So the first one we are going to graph is x is less than negative 4. Can I go ahead and graph that one the way that it is? Yes, I have a variable by itself. It's x. Okay. What's one of my special guys? Is it ahoy or is it avux? It's avux. And vux is what kind of lines? Vertical. Vertical lines. So where is that vertical line going to go? When x is negative 4. Good. 1, 2, 3. Remember, this side is my negative x's, so this is negative 4. Is my vertical line going to be dashed or solid? Dashed. Good. And I want to shade all x's that are less than negative 4. So am I going to go to the left or am I going to go to the right? Left, yes. Below, left, less than. They all got L's. Okay. Also, what's cool with x's, the arrow kind of points. See how it's pointing? That way. Okay, I want you to shade that direction. But these are all the x's that are going to be less than negative 4. All right. Okay, time to work with 3x plus 2y is less than or equal to negative 2. Okay, write the equation down. 3x plus 2y less than or equal to negative 2. What do I always move first? How do I move the x? Subtract. So subtract 3x to the other side. I am left with 2y on the left. The right side has a negative 3x. It also has a negative 2. Is my y by itself? What do I have to do? Divide by what? I heard it, 2. Good. Each and every piece gets divided by 2. Does dividing by 2 flip my sign? Does dividing by 2 flip my sign?
No.
No, because it wasn't negative. You just got to watch the negatives, okay? So we have y is still less than or equal to negative 3 over 2. Can't do anything to it. It just stays. How about negative 2 over positive 2? What is negative 2 divided by positive 2? Negative 1. Yeah. Okay. So where is this line going to start? Where my y is negative 1, all right? And how am I going to move? Good. Down 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. 1, 2, 3 over 2. To go backwards, we can go up and then back. So I'm going to go up 1, 2, 3, backwards 2. 1, 2, 3, backwards 2. 1, 2, 3, backwards 2. Will these be connected by a dashed or solid line? By blues. Blues will be solid. Good. Are we going to shade above or below this time? This one is below. Good. We are less than. Our symbol kind of looks like an L, so we're going down. So the part that they are overlapping is this little piece on the very far left side. Okay. It had to be under both of them. All right, here's your question. Is the origin a solution to the system? No, it is not. It's not a solution to anything. Look, it's out here where there's no shade at all, right? So 0, 0 is not going to work for any of my inequalities. I might get to do one more. Let's do one more. All right, moving on to number 5. Okay, moving on to number 5. Our first equation is 4x minus 5y is greater than or equal to 35. We got some moving to do. What do we always move first? The x. And how do we usually get to move it? By minusing. Yes, so let's subtract 4x over here. I'm left with negative 5y greater than or equal to. Now I have a negative 4x and a negative 35 on that side. Now what do we have to do? There's a negative 5 with my y. How do I get rid of that negative 5? Divide. Good. I am dividing by negative 5. Does that flip my sign? Does this flip my sign?
Yes.
I divided by a negative. This does flip my sign. So now we're going to go under the line. It's below. Less than. Negative 4 over negative 5. The numbers don't do anything, but negative over negative becomes a positive. 4 over 5. How about negative 35 divided by negative 5? Positive 7. Just erase your name off my board. Yeah, just erase it. Thank you. All right, so where does this line start? Positive 7.
But you can't go
1, 2, 3, 4, 5, 6, 7. Yeah, that's why I wanted to do this one. So yeah, our slope is up 4 and over 5, but if I go up 4, I'm off the grid. So, Torian, what'd you say to do instead? Go down and backwards. 1, 2, 3, 4. Backwards. 1, 2, 3, 4, 5. 4, 5. Am I going to connect this with the solid or a dashed line? Is this one solid or dashed, guys? It's going to be solid. How do I know? It has an equals to. Good. And are we going to shade my y's that are less than or greater than the line? They're going to be less than. So all of my y values are underneath it. They are all smaller than the line. All right? Okay. Erase your name off my board. Erase your name off my board. Just swipe it. All right. Now we have x plus y is greater than negative 2. This is nice. I only have one thing I have to do, right? Get that x out of my way. How am I going to get out of my way? There you go. Minus that 2 over. We have y greater than, there's a negative x, and there's a negative 2. Where does this line start? Where y is negative 2. And how is it going to move? Down 1 over 1. I think these are the most tedious ones. Thank you. Goodness. Solid or dashed line? Good. Dashed. And are we going to shade above or below? We're going to go above. So find that negative 2. We're going up. So everything above my blue line. Yeah, blue is dashed. Red is solid. Blue is dashed. So our region, again, it's this little triangle on the right side. Famous question, what is it? Is the origin a solution? Yeah, it is. Look, he's in the green. All right, good job today.